Alright, so we have learned about absolute value before, so now we're going to, in 2.7, talk about the graph of absolute value, more so than evaluating or solving absolute value like we did in Chapter 1. So we need to remember first what absolute value is, and that's this right here. It's talking about the distance a value is from 0. So we have the fact that if I wanted to be, say, 3 spaces away from 0, I could either be at 3 or -3 and be 3 spaces away. So if I look at graphing then, this y equals absolute value of x, if I make myself a t-chart, if I plug in, let's do 4 points here. Okay, if I plug in -2, the absolute value of -2 is +2. So if I plot the point, -2, 2, there's 1. Okay, if I do -1, absolute value of -1 is 1. That's this point right here. And if I plug in 0, absolute value of 0 is 0, and 1 and 2. So what you're going to find is that you're going to get a graph that's linear on both sides. And depending on which side you're on, this side has a slope of -1, and this side has a slope of 1. And I know that because if I pick 2 points, if I go from 0 to 1, I had to go up 1 and to the right 1 to get to the next point. Likewise, if I were to go from this point to this point, I go down 1 and to the right 1. Okay, this is what we call the parent function for absolute value. That means all absolute value functions are some variation of this graph, whether we move it up and over, whether I make it narrower or skinnier, whether I reflect it downwards. That's what we call a transformation. Okay, so we can transform this parent function to fit our needs. Translation simply moves the graph up and down or left and right, but does not change how wide or any of the orientation of the graph. Okay, it's going to have the form for just a simple translation that looks like this. Okay, it's shifting, whatever's inside of here shifts the graph left or right, and the k value shifts it up or down. So our vertex in this case is going to be at h, comma, k. So let's look at graphing these. Okay, so in this one, k is 0. So my vertex is going to be h. Now I notice x plus 2, so that's the same as x minus -2 plus 0. So my vertex is -2, comma 0. That's here. Okay. Now in order to get the shape, if I look at the number that's outside here, that's going to tell me how to, kind of like a slope of a line, how to alter my graph or how to graph it. Since I have a slope of 1, I am going to the right, go up 1 and to the right 1, up 1 and to the right 1, and so on. And then likewise to the left, I'm going to go up 1 and to the left 1. Oops. Sorry. So -2, 0, up 1 to the right 1, and then up 1 to the left 1 as well. Now how I know that's going to be the case too, I can actually pick some x values and plug them in that are around my vertex. Okay, so I'm going, since I know the vertex is at -2, I'm going to go 1 on either side. And let's go a second on either side, just for good measure. So if I plug in -2, absolute value of -2 plus 2 is 0. If I plug in -3, -3 plus 2 is -1, absolute value of -1 is +1. If I plug in -4, I get the absolute value of -2 is 2, and I get the same y values if I use the other two x's. So I can just plot those. And I have a hard time with this pen drawing straight lines on here, so these are supposed to be straight through those points. Okay, so for B, my vertex is h, k. So I've got -1, negative 3. And again, I still have a slope of 1 since there's no number out in front, so I can just go up 1 and to the right and left 1 from each point. Whoops, sorry. And there's my graph. And last but not least, C. My h is negative 2, my k is 4. We're following the function y equals x minus h, absolute value, plus k. Okay, so I've got negative 2, positive 4, and I only have space to go up 1 and to the right 1, and up 1 to the left 1 in both cases. So it looks something like that. And if I'm not sure, like I said, how to use the slope, pick some points. Once I get my vertex, which is in this case negative 2, 4, I'm going to go negative 1, 0, and negative 3, negative 4. So if I plug in negative 1, I get negative 1 plus 2 is 1, absolute value of 1 is 1, plus 4 is 5. And for this one, I should get out 6. 0 plus 2 is 2, absolute value is 2, plus 4 is 6. And I should get the same for these two. Alright, I can do more than just translate. I can also affect how wide or skinny the graph is, and that's by putting a number out in front. Y equals mx plus b, for just a plain old line, the m is what controls how quickly or how steep the line is. So this is we're going to treat like slope. So if I have the graph y equals 3 times absolute value of x, my vertex, my h is 0 and my k, so my vertex is at 0, 0. And in this case, my slope is 3, so I'm going to go up 1, 2, 3, and to either side 1. So this one makes it skinnier, closer to the y-axis. If I do the same thing with y equals 1/4 times the absolute value of x, I still have 0, 0. Now I'm going to go up 4 and to the right, or up 1 to the right 4. 1, 1, 2, 3, 4, and to the left 4. So it makes that one really super wide from the y-axis. And last but not least, the same ones, negative 2 times this absolute value of x still has a vertex at 0, 0. But now I'm going to go down 2 and to the right and left 1. And I get my graph. So anytime the number out in front is negative, it's going to flip your vertex or flip your graph so that it's down instead of up. Okay, so here's just a recap of how we graphed. Find the vertex based on this being our equation for an absolute value function. Okay, then we're going to use A, which is, we're going to kind of treat like slope, to find each point after knowing what our vertex is. So we plot the vertex and then we use A to find the next point to the left and to the right. So we'll do one of these together, and then and then you'll do some of the others. Okay, so the first one, our vertex, x minus h, so that's going to give me a positive 3, positive 1 for my vertex. And then I have a slope of 2, so I'm going to go up 2 and to the right 1, and up 2 and to the left 1. So, so 3 points. If I said give me 3 points on this graph, 1 being the vertex, I would have 3, 1, and then I'd have 4, 3, and I'd have 2, 3.